Hello and welcome to the Daily Space for today, February 11th, 2020. My name is Dr. Pamela Gay, and I am here to put science in your brains. Today's episode starts with news that supercharged light pulverizes asteroids. Now, I'm not going to lie. When I first saw that phrase, pulverizes asteroids, I assumed this was purely clickbait. Pulverizes makes me imagine breaking asteroids up into smaller and smaller pieces. And light in general is going to melt things rather than break things. But there is exceptions. And this not totally clickbait title is actually talking about an exception that is clever and actually has a magnificent name, the YORP effect. The YORP effect is well known in our own solar system. Sunlight hits an asteroid, and due to asymmetries on the outside and inside of the asteroid, that light, well, it can set the asteroid spinning in a not entirely predictable way. The more light, the more spin. And it turns out, if the light gets strong enough and the resulting spin gets fast enough, asteroids will actually spin themselves apart. In new software models from the University of Warwick, astronomers have calculated that the bright light coming off evolved giant stars is sufficient to spin up a system's asteroids to break up speeds. Within as little as 1 million years, this effect can actually reduce the majority of the objects in a system to just 1 to 100 meters in diameter. In this new research, published in the monthly notices of the Royal Astronomical Society with lead author Dimitri Veras, we see that as a star expands out and becomes a giant star, its increase in luminosity, well, it's 1,000 to 10,000 times. Any asteroids that survive the star's expansion aren't simply going to be eaten, they're going to get blasted with light and accelerated to breakneck rotational rates, sometimes at a rate of 1 rotation per 2 hours. At that point, with that kind of rotational speed, gravity isn't enough to hold a large asteroid together, so it flies apart. Many asteroids like Bennu and Ryugu are just piles of rubble that will become clouds of debris, which admittedly some of us may look forward to happening to Bennu. Smaller asteroids, while lacking a lot of gravity, have stronger chemical bonds holding them together, and with their smaller radii, can withstand a higher rotational rate. Objects the size of Pluto and larger, well, these round worlds have sufficient gravity that they should survive the YORP effect. In between roughly 100 meters and 1,000 kilometers, though, objects will go through repeated breakup events until everything is shredded as small as possible. Like all the best science, this paper makes a prediction about how white dwarf stars, the results of those giant stars, and those advanced giant stars themselves, should have debris disks around them. These disks may actually evolve to look like Han Solo's asteroid belt as the rocks collide and migrate in toward their white dwarf star. A lot of debris will end up, well, falling into the white dwarf, polluting its atmosphere in ways that should be observable. I really like this story. It has a great named effect, the YORP effect, and it actually gives us Han Solo's asteroid belt. It includes mass destruction, and it makes observable predictions. It really doesn't get better than that. From death of solar systems, we now turn to their formation. One of the most common questions we've seen is what separates a failed star from a giant planet? From the physics side, it's easy. Brown dwarfs, which are the fancy name for failed stars, are large enough to undergo temporary nuclear burning as their insides hit temperatures and densities capable of fusing heavy hydrogen. Like tritium and deuterium. These things, they burn in the cores of brown dwarfs, but only temporarily. What makes something a star is they're big enough to burn hydrogen and become a star. What is less straightforward is determining if the formation of failed stars and planets are the same or different. For instance, could we have had a star in the position of Jupiter with, well, planets orbiting inside and outside of it around the same thing? I'm being asked, are there slides? I screwed up. There wasn't a slide of the first one because it was just computer models, but we do have a slide for this one. Thank you, chat, for the question. Screen. It didn't switch. Let's try this again. That's not it. Let's try clearing that. You are finding the fail mode of all of the hosts of CosmoQuest. There we go. So here's the slide that's relevant to this one. So imagine, if you will, is it possible to have a solar system with a star where Jupiter is and Venus and Neptune orbiting like planets the way they do now? Does that physics work? And the question, well, it may have an observational answer. New research from the University of Texas tries to make sense of this kind of a problem by looking at star systems with brown dwarfs and giant planets to see if they can observationally figure out just what's happening. Using the Keck and Subaru telescopes in Hawaii, this team, led by Brendan Bauer, looked at 27 systems with either a brown dwarf or a giant planet, and all these systems also had a regular star. As they observed how the smaller object orbited the normal star over years, this is a many-year-long observational project, this team, well, they modeled what all of those objects were doing. While this wasn't enough information to precisely measure the orbits of those planets and brown dwarfs going around their stars, it was enough to constrain what kinds of orbits were possible. And this was good enough to see that while giant planets have a tight distribution of mostly circular orbits, the brown dwarfs tended to have much more elliptical orbits. And this difference provides our answer. Solar systems form through the collapse of a large cloud of material. A star will form in the center of that collapsing cloud, with planets forming in a disk around its center. These planets form through the accumulation of dust particles that collide together and then collide to build bigger objects that then gravitationally pull in more and more matter until we have planets in circular orbits. Binary stars, however, form through the collapse of two separate clouds that are orbiting one another and end up in, well, every possible orbit around each other. But while they end up in all kinds of orbits, generally they aren't circular orbits. This new data from Baller's team shows that brown dwarf orbits are consistent with them forming like stars. This limits just how interesting solar systems may be, but places a nice clear boundary between stars and planets. And we have one more news story for today. And in that final news note, a team of planetary scientists up in Chicago are looking at grains of lunar dust to test a new way to study lunar and planetary samples atom by atom. By shaving samples of dust grains into 100 atom thick sheets. A piece of paper is thousands of atoms thick, just for perspective. This team is probing how water and helium formed on the moon and getting a handle on the way dust is altered by exposure to micrometeorites and radiation. Doctoral student Jenica Greer is producing remarkable images like we're showing here, which you can just see all the crazy details of molecules and crack lines between minerals. And this technique has the potential to unlock new ways to do systematic science with materials previously deemed useless for science. For instance, this technique, called atom probe tomography, could be used to study the dust that came back in the astronauts' spacesuits from the Apollo era, and all the other fine particulate that ended up in pretty much everything in the Apollo missions. This material had previously been considered useless for science. This technique will also expand what science can be done with asteroid samples from Ryugu and Bennu. And when that science is published, well, we'll be here to share it with you right here on the Daily Space. But for now, we just have a really cool technique that we wanted to let you know exists. And that rounds out our show for today. This has been the Daily Space. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. This episode was written by me, Dr. Pamela Gay, and will be produced by Susie Murph. Thank you. We are a audience-supported show, and we are made possible through your generous donations of, bits, subs, and dollars over on patreon.com. I'm going to pause for a minute and torture my doggos and see if I can figure out, hi, I see you, how to get dog cam up where the slides currently are. I rearranged my setup just enough that I can now actually do that while sitting at my desk, which is very, very exciting. All right. So there is dog cam. You ready for this? You ready? Go get it. All right. Okay, so I am now going to hang around and answer your questions. I'm doing this very gently because my trackpad's batteries chose this morning to die, and this left me with a slightly dangerous trackpad. Your bits, your subs, your donations may allow me to eventually replace this highly dangerous object that I am currently using to control my computer. Do not drop a trackpad. It turns out they shatter worse than iPhones. All right, so scrolling up to the top to see what questions we have. I think I have finally figured out all the camera things that I need down here, and this brings me no end of joy. So we now have a set dog area where the dogs are now frantically finding every possible Cheerio. Hello, everyone. I'm not going to say everyone's names today. I am going to ask Larry Weird what he means by deprogramming on. Scrolling for questions, scrolling slowly because dangerous pad. I love all the death to Benny, die Benny, so many rocks. Yes, it's evil. Clickbait should die too, but remarkably, that story wasn't clickbait. Benno is almost all pieces cuddled together. It is true. And it is nice to know that if it doesn't get consumed by the sun someday, it will get yorped apart. We need more objects to get yorped apart because that is just a fun phrase to say. Scrolling some more. Not a lot of questions today. Broken Symmetry is quoting songs. You spin me right round, baby, right round. I'm not going to have that stuck in my head. Oh man, now you're going through all the lyrics. Sorry for missing the slides at the very beginning. So Larry asks, would the planet that is getting blasted with the giant star's light have high radiation? So this is one of those things where I have to say scientists are really bad at how we use language. There's certain words we can't be trusted with. Radiation and theory are the top two on the list. Radiation interchangeably means every color of light and particles flying around at high velocities. Basically, anything that can impart energy that is small might potentially get called radiation. Now, in this particular story, what they mean by a high radiation environment is it's really bright light, lots of bright light, super bright light, because the star is giant. And more surface area means more places for sunlight to come out through the surface of the star. So here, it's not going to be dangerous gamma ray, X-ray, that kind of stuff. And it's not going to impart radioactive decay, another bad way we use the word, onto the surfaces of planets. It's just going to blast things with light. So it's all the photons, but not that many of the dangerous photons. These are red stars. They peak in the red. Okay, so let's see what other questions we have in here. Yeah, don't breathe the regolith, broken symmetry. That is right. Do not breathe the regolith. Scrolling to see. Thank you, Stumpy Ahoy, for the bits, just to say thank you again. There are no dogs in the dog bed, but Stella's going to sleep near the dog bed. Weird dog. So Veronica Cure asks, how does a strand of hair compare to the atom's thick slice of regolith? That's going to depend on your strand of hair. So some hair is roughly the same thickness as a piece of paper. Some hair is thinner. Some is actually thicker. Your mileage may vary. So the slices of regolith that they're making are presumably significantly thinner than most sheets of paper. Than most strands of hair. I hope that vaguely made sense. So your standard piece of letter-sized paper, which is uniform in size, unlike hair, your standard piece of uniform letter paper is a few thousand atoms thick. The slices that they're making of dust are roughly 100 atoms thick. So that slice is 1/10 the thickness of a piece of paper. That said, a factor of 10 isn't a lot, and human hair varies in size a lot. So you're going to have some strands of hair that are the same thickness as a piece of paper, some strands of hair that have had a really hard life that are the same thickness as that regolith thing. This is why it is generally better to use a piece of paper than a piece of hair for comparison. But the reason that we always use a strand of hair at arm's length for arc second is because trying to hold a piece of paper at arm's length is hard. Whereas a strand of hair, if you're off by a factor of 10, we're not going to worry about it. Stumpy Ahoy says, is that an Apple Magic trackpad that you have? I have an unused spare that I could send you. Oh my goodness. That is exactly what this is. They can get broken. Rather dramatically, it turns out. If you have one that is going to do nothing ever but sit on a shelf, and you have no use for it when you're traveling and shit like that, I would not say no. I do have a mouse that I can generally use. The mouse just ran out of battery today. So while I have fantasies of replacing this horrible thing, it is a sufficiently low priority that I can just use the mouse. I can't get a good light angle on this. Come on. Aha. Now you can start to see what I did to it. Start. But I can also just use the mouse most of the time. I'm going to babble. Hit me up in Discord. So Larry is like, Tinker is programmed to react to thank you from Annie. Recommend reinforcing the phrase, make it rain instead. That is true. My dogs also respond to thank you now. Planetary Pan says, a lot of people use theory when they mean hypothesis, and I have never actually heard a scientist talk about their hypothesis for anything. Scientists always talk about, I have a theory for this thing, which means we use theory for so many different things because we're terrible. So we don't end up with giant planets orbiting brown dwarfs. So we have giant planets orbiting stars, and we have brown dwarfs orbiting stars. And giant planets and brown dwarfs are too close in size to end up forming together out of the same cloud of stuff. I don't know if that helps. And the thing about brown dwarfs is they only give off light for a very small period of time. Hello, everyone. Arctifus also points out that arm lengths also vary. This is true. There is so much wrong with the way that we teach that a arc second is the size of a strand of hair held at arm's length. It is simply meant as a vague attempt to get a order of magnitude into people's heads. It's okay, Wayne Johnson. Being late just means that you have to go watch the video. I'm glad you're now less confused, Larry. So do we have any more questions out there? Tomorrow, Annie will be here with our weekly rocket roundup. Later today, I may be programming on stream. I am borrowing Favorite Human for a couple of days. He's coming out here on a scouting expedition. Zine is asking, are there models of how far out planets can form from their host stars? I'm sure there are. I don't know the results. In general, we think that planets form closer in than where we see them in our solar system, and Uranus and Neptune probably got flung outwards. But the problem is we're still getting new observational data on how solar systems form, and that observational data is always very different from what we expect. It turns out no one really has a thorough understanding of how star systems form. We just have big picture understandings. So Veronica asks, is YouTube getting enough traffic that we can start adding ads yet? No, not yet. Not yet. Go watch on YouTube periodically, folks. So yeah. Exercise is the devil's work, Larry. I agree. On Wednesdays, when Annie is doing Rocket Wednesdays, I'm usually on my elliptical machine. And it does not go well. It does not go well. But I make myself go for the length of Rocket Wednesdays. I like weeks when there's fewer rocket launches. Okay. Do we have anything else out there question-wise? I'm going to be sad this week, Binary Ablaze, aren't I? So can you spell your name phonetically? Arcodifus? Because I want to know how to spell that. How to say that. I know how to spell it. Okay. Thank you, Broken Symmetry. Thank you. Do you guys want this? Go over there. I'll be happy if I can train them to run over there for bits. Just call you Arc. Okay, I can do that. You have just such a cool looking name. don't know where the syllable breaks are. And my dogs do have literal fuzzy butts. So Ark asks, if photoplanetary disk bulges up in the middle, shouldn't larger planets be formed closer to the star? So there's two different forces going on. You have, thank you for the more bits. Go. Oh, camera down. Camera down. Hold on. Sorry about that. You need a counter for how often the camera gets knocked down. That is true with my cameras. Okay. So the way the way it works is you have everything gravitationally falling in and beginning to rotate. The rotation flattens out the disk. Now, the sunlight in the center, when that star first turns on, which it does before planets have really had a chance to form, it pushes all the lighter elements out of the center of the solar system, leaving behind the heavier elements that end up forming the rocky worlds that generally are in the centers, in theory, of solar systems. Further out, you have more hydrogen and helium and more material available to form gas giants and ice giants. And then everything migrates. And we're still trying to figure all of this out. But it's that blast outwards by light pressure, that is the reason that we believe that we get larger worlds further away from stars. Let me see what else we have in here. Jay Sarah says, not a question, but I did just get out of lecture on stellar spectroscopy from Roberta Humphreys and finally learned the origin of the OBAFGKM system of classification. Yes, this is what happens when you name your spectral lines and then figure out your spectral types rather, and then figure out what they mean. Early on, for those of you who weren't in Dr. Humphrey's class, early on when folks were studying stellar spectra, they saw the lines in the spectra, the absorption lines from hydrogen, calcium, so many different elements. And they didn't fully understand why they had different strength lines in different kinds of stars. And so they ordered them up, and this was work that was done by women at Harvard, and I'm trying to remember the name of the woman who funded this work, and I'm failing right now. Annie Jump Cannon was one of the women who was influential in figuring out the final, how everything fits together. So they labeled all of these different spectra, they classified them, they figured out how they all fit together. And then it was later when Russell and Hertzsprung, who are two separate scientists working completely separately, both figured out that you can order the stars by color or temperature and by luminosity to create a color magnitude diagram with this beautiful main sequence of stars that are burning hydrogen in their core and then other groupings of stars by evolutionary phase. When they did that, it was realized that these spectral lines correspond to a temperature range, and everything had to get reordered. So O stars are hotter, which is why they're first, but they have very few spectral lines because they're so hot, everything is ionized. This is just how the ordering came out. So it's a cool set of stories, and I'm really bad at remembering names. Fluff everywhere. Yes, that is the story of my entire house is fluff everywhere. Um, Larry asks, who said if someone tells you they know how planets form, they're lying? That was me. That was me. Um, it was a very quick tour of the stream room. That is true. It was not an intentional tour of the stream room. All right. Are there any more questions out there? You are welcome, Larry. You are welcome. I moved my questions to be right next to the camera, so it's much easier to read the chat now. If there is nothing else, I'm going to go do a quick devouring of lunch, a mad attempt to make my house less displeasing to my sensibilities before favorite human of Annie's arrives. And later on today, if all goes well, I will be potentially coding on stream or at least coding. Any of you out there who have it in you to volunteer, we are looking for coders to help us out on a myriad of different software-related issues as we rebuild CosmoQuest into, well, what we always dreamed it could be. So please consider helping us out. Wayne comments, lunch was 6 hours ago. Well, strangely, you are 6 hours in my future. Wayne and I are actually 90 degrees or a quarter turn of the planet apart. I live near 90 and he lives near 0. So I am going to be off like a speeding turtle. But before I do that, I would like any recommendations you may have on who I should raid. And one last time before I go. This has been the Daily Space. We are a product of the Planetary Science Institute, a 501c3 nonprofit. We are here thanks to the generous contributions of people like you that are tax deductible where the law allows. Please consider supporting us if you can. Every dollar bit sub patronage over on patreon.com/CosmoQuestX. It all adds up to allow us to pay for our software, servers, and staff. I am your host for today, Dr. Pamela Gay, and this show will be produced by Susie Murph. Please consider subscribing to us wherever you may find podcasts if you're a podcast kind of person. If you ever miss an episode, check us out over on YouTube where everything is archived. But for now, that's all I've got. So wherever you are in the world, have a fabulous morning, evening, or afternoon, and we'll see you on the other side. Bye-bye. It won't transition. It's swirly rainbowing. That's so frustrating. So I tried to transition gracefully. I can now do nothing. I can't stop the stream. I can do nothing due to a whirly rainbow. I did push the button. I pushed the button and it sat there. I have a massive whirly rainbow. Let me see. There's nothing I can do except for maybe force quit the app. Okay, this is going to be the rudest possible end of stream because I'm just going to force quit everything. So to all of you that I wish I could thank with the chat, not going to happen today because I broke it. All right.